Hi there guys, in this video we're going to be looking at matrices and what a matrix is and some really basic operations with matrices, adding, subtracting, multiplying by a scalar, that kind of stuff. Now a matrix is not what you see on the screen here, despite how cool that would be. A matrix is just an array of numbers that we need to learn how to manipulate and use to solve problems. So here's what the syllabus says about what we need to know. Add, subtract and multiply matrices, including multiplying by a scalar. Remember, a scalar from when we're doing vectors is just a constant, a number. That's what I'm going to do here. Examine the algebraic properties of matrix addition and multiplication, including commutativity for addition and not for multiplication. So we need to know when we're multiplying matrices, it's a little bit trickier. It's a little bit stranger. So we need to know some of the properties of that when we multiply matrices. There is no division. That's something else that you're going to learn. We're going to define special properties of identity, unit, singular, diagonal, row, and column matrices, all of those things. So I'm going to take care of those first basic ones in this video, and we'll go on and do the others in the next videos. So first thing we need to know is here we've got some arrays of numbers here, and we've got three matrices. First thing we need to define is the order of a matrix. Okay, so the order of a matrix, or sometimes people say it's the dimensions of a matrix, is we'll say we've got an m by n matrix, and what that means is you've got so many rows and so many columns, and we always do it in that order: m rows and n columns. So if we look at matrix A, for example, matrix A has 2 rows, 1, 2, and 3 columns. Okay, so the way that we write the dimensions or the order of this matrix is we say that this is a 2 by 3 matrix, 2 rows, 3 columns. Matrix B also, as you can see, is 2 by 3, and matrix C is what we call a square matrix, and it's 2 by 2, 2 rows and 2 columns. Now, as you probably can imagine, adding matrices is really easy. You just add the individual entries in the matrix. So if we were going to do A plus B, and by the way, most of the time for matrices we use these square brackets, but sometimes people do use curly brackets as well, but I normally go with the square brackets. So A plus B is real easy. 1 plus 3, 2 plus 5, 4 minus 2, 0 plus 1, negative 4 plus 0, and 5 plus negative 2. So that is the result when we add the two matrices together. Now, that's the same for B and C. When we subtract, you just add and subtract the corresponding elements in the matrix. Note here that you cannot add and subtract matrices of different order. So I cannot do A plus C. It doesn't make sense. Or B plus C, or C plus B. The matrices have got to be the same dimensions, same number of rows, same number of columns in order to add or subtract. For part D, it may not surprise you that 5 times C is just 5 times every element inside C. Okay, so 15, 5, and negative 25. So when we're multiplying a matrix by a scalar, we multiply every element inside the matrix there by that scalar. So that is what 5C would be. You'd have to do a little bit more work to do E, but I think you get the idea. 3 times B, then subtract off 2 times A. I don't think that's too hard. Alright, let's talk about multiplying matrices now. Now it gets a little bit funky. Here we go. We can only multiply matrices if, and here's the definition here, if the number of columns in the first matrix equals the number of rows in the second matrix. Okay, so this is important here to note that A times B and B times A in matrices are not the same. They're not commutative. So unlike addition for matrices, A plus B and B plus A, you get the same thing. When we're multiplying two matrices, AB and BA are not necessarily the same. So that's what we saw in the syllabus there, that we need to understand that. So I'm going to show you how to multiply these as best I can. So let's start by writing down the dimensions of each of these matrices. So we've got A, which is a 2 by 3 matrix, 2 rows and 3 columns. B, which is a 2 by 2 matrix. And C, which you can see has 3 rows and 1 column. So this is a 3 by 1 matrix. And we'd say C is a column matrix because it just consists of 1 column. We may get other matrices that might look like this, and we call that a row matrix because it only consists of 1 row. So that also defines some of the terms at the start. Okay, so let's do A times B. I'm going to show you how to do that. Alright, so we've got 1, 2, 3, 1, 4, 0, and we're going to times it by B, which is 2, 1, 3, negative 1. Okay, so this is a 2 by 3 matrix, this is a 2 by 2 matrix. In order for the two matrices to be able to be multiplied, this number and this number must be the same. The number of columns in the first one must be the same as the number of rows in the second matrix. What is important here? In this case, not the same. So we cannot multiply A and B together. It will not work. Could we multiply B and A? Let's go for it now. Okay, so let's get matrix A and let's move him over there. And let's put B at the front. So matrix B is 2, 1, 3, negative 1. Okay, so we've got a 2 by 2 matrix and we're multiplying it by a 2 by 3 matrix. Note, these two numbers are the same, so in this case we can do the matrix multiplication. The matrix that we end up with here is a 2 by 3 matrix. So that's the way that you can tell the dimensions or the order of the matrix that you end up with. It's just those two numbers. The first one, in this case the number of rows in the first one, number of columns in the second one. So we're going to end up with a 2 by 3 matrix. So I could kind of sketch out the answer of what it's going to look like. It's going to have 2 rows and it's going to have 3 columns. So it's going to look like that, a 2 by 3 matrix. Here's how you do it. What you're going to do is you take the first row of the first matrix and you turn it on its side. In matrix things we call it the transpose, when we transpose the rows and columns in a matrix. So I want to take that first row 2, 1 and you turn it on its side so it becomes a column. Okay, so rather than 2 and 1 here, it becomes 2 and 1 like that. You then move that across and multiply by each of the columns in the second matrix. So let me show you how that's done. So 2, 1, think of this first row here, think of it turning on its side so it becomes 2, 1 like that. You multiply and add. So you take the first row, you turn it on its side, you move it across, you multiply and add. So that first number there is going to be 3. 2 times 1 plus 1 times 1. You then do the same thing for the second column of the second matrix. We've still got 2 and 1, we move it across to here. We multiply and add. 2 times 2 plus 4 times 1 gives me 8. Okay, you might need to watch that again to make sure that you've got it. So that first matrix there was 1, 2, 3. Okay, let's do it again for the last one. So you've got our 2 and 1, we turn it on its side and move it across to the 3 and 0. We've got 2 times 3, which is 6, plus 1 times 0, giving us 6. Okay, finish off. What are the 3 numbers on that bottom row there? Here they are. So again, we get these numbers in the bottom, we turn them on their side and we move it across. So just got some room here, which is good. So we've got 3 and negative 1, we've turned it on its side, we multiply and add. So 3 times 1 plus negative 1 times 1 gives me 2. Okay. Do it again. 3 times 2, 6 plus negative 1 times 4 is negative 4. 6 minus 4, 2. And once more for the last one, turn it on its side, we get 3 times 3, 9, plus minus 1 times 0, which is 9. There is the result of doing B times A. Notice AB wasn't even possible, but we have got an answer for BA here. Now, can we multiply A and C? We've got a 2 by 3 matrix times a 3 by 1 matrix. The number of columns in the first one is the same number of the rows in the second one, so we're good. So I'm going to do one more here. A times C. So we've got A, which is 1, 2, 3, 1, 4, 0. And we're multiplying it by C, which is 1, 4, 1. Okay. A 2 by 3 matrix multiplied by a 3 by 1 matrix. Again, these two numbers have got to be the same. Okay? And the matrix we end up with is a 2 by 1 matrix. So what is a 2 by 1? Remember, rows, columns. So we're talking about a matrix that has 2 rows and 1 column. So it's just going to look like that. Okay, let's do it. So the 1, 2 and 3 in the top row here, turn it on its side, move it across. So you've got to literally think of that 1, 2, 3 looking like this. 1, 2, 3. We multiply and add. That's what it looks like. So we've turned the 1, 2 and 3, we've transposed it so it becomes a column. We then multiply by that first row and add. So here we've got 1 plus 8 plus 3. So that gives us 12 for the top number there. Let's do that again for now the bottom row. Okay, so we've got 1, 4, 0. Turn it on its side. 1, 4, 0. Multiply and add. Cool, you got it? So 1 plus 16 plus 0, 17. That's the result of going A times C. Is that matrix there? 12, 17. Now the other one's here, C by A. So for C by A, we've got C, which is 3 by 1, and we're going to times that by A, which is 2 by 3. Clearly, these two numbers not the same. We can't do C by A. What about B squared? B squared is called a square matrix. A 2 by 2 times a 2 by 2. The 2's match up, and we're going to get a 2 by 2 matrix. So we can do B squared by doing the same thing. So I'm going to do one last one here, and we're done. B squared. So we've got 2, 1, 3, negative 1. Okay, 2 by 2 by a 2 by 2, so we end up with a 2 by 2. Let's do this quickly. 2 and a 1 on the top line. Turn it on its side, move it across. 4 plus 3, 7 for the first one. Turn the 2 by 1 over, turn it on its side. That's what I'm doing in my head. Okay, I'm not going to write this any more times. That's what I'm doing in my head. 2 minus 1, which is 1. Next row, take the next row. So we've got 6 minus 3, which is 3. And then 3 plus 1, which is 4. And that's B squared. That's it. That's how you multiply two matrices together. This, of course, can be used in context. And this is where matrices become really, really helpful when we see them in context like this. So this manufacturer here has got 3 products, A, B, and C, each requiring a certain number of units of commodities, P, Q, R, S, and T. Matrix X below shows the number of units of each commodity required to make one of each product. So to make product A, cereal, whatever it is, we need 1 of P, 1 of Q, 2 of S, and 3 of T. Now we've got the costs to the manufacturer of each of P, Q, R, S, and T. And then what we want to do is form a product that it explains and explain what information it displays. So if we say 1, 1, 0, 2, 3, 1, 1, 2, 1, 2, and 0, 1, 3, 0, 3. That's our matrix X. Now I'm going to just put the costs of each of these in another column matrix at the side here. So we've got 200, 100, 50, 400, and 300. Okay. Let's just check if we can do this matrix multiplication. This first matrix is got 3 rows and 1, 2, 3, 4, 5 columns. The matrix on the end here has got 1, 2, 3, 4, 5 rows, and it's got 1 column. Alright, so because those two numbers are the same, we can multiply this matrix, and the result is a 3 by 1 matrix. In other words, 3 rows and 1 column. So that's what it's going to be. Alright, cool. So let's do it. So I'm going to do this really quickly. So we've got 200 plus 100 plus 2 times 400 plus 3 times 300. That's going to be my first value up there. And when we do that, we get 2,000. You can check that I've got this right. So that first one there is 2,000. The next one, 200 plus 100 plus 2 times 50 plus 400 plus 2 times 300 is going to be 1,400. Okay, and then the last one, we've got 1 times 100, 3 times 50, and 3 times 300, which gives us 1,150. Cool. Now what does that tell me? That tells me the cost of producing products A, B, and C, the total cost of producing them, A, B, and C. That's the total cost. So it costs us $2,000 to produce product A, given the individual costs of all the components. And you can see that product A takes 1 of P, which is 200, 1 of Q, which is 100. So, I mean, you can just add it up. The power in this matrix method is that you can do this for huge matrices, and a computer can do it really, really quickly. So here we've just got 3 products and a few ingredients. What if there was 50 ingredients and 200 products? That's where matrices comes into its own. Okay. That's a basic introduction to matrices.